Welcome to Mythos AI, your source for Cliff's Notes on complex subjects. Join Anna and Phil for yet another engaging conversation.
Welcome to this deep dive where we're going to be examining AI for science. Specifically, we're diving into this Google DeepMind paper called A New Golden Age of Discovery, the AI for Science Opportunity.
This paper really lays out a vision for how AI can become like this really powerful tool for scientists, helping us, push the boundaries of knowledge in ways that we really haven't even imagined before.
Yeah, they argue that we're on the cusp of a new era of science, driven by AI's ability to tackle some challenges that traditional methods just struggle with.
And it's not that the traditional scientific method is like flawed. I mean, it's served us well for centuries. But we're now facing a situation where the sheer volume and complexity of data is exceeding our capacity to analyze it effectively.
It really is. I mean, fields like genomics and astronomy and particle physics, they're just generating data at this unprecedented rate. I mean, think about genomics. We're talking about the entire genetic code of organisms, billions of data points.
Billions. And then in astronomy, I mean, you have telescopes collecting petabytes of data every night, capturing images of distant galaxies. I mean, you name it, cosmic events.
It would take teams of scientists, lifetimes, to manually sift through all of this data. So that's where AI really offers a solution.
Right. And AI algorithms, especially those based on machine learning, excel at processing these massive data sets, identifying patterns, and extracting meaningful insights.
They can analyze these just enormous data sets and identify, correlations or anomalies that would have been missed by human researchers. It's like this tireless research assistant that can just scan through mountains of data and just pinpoint the most interesting, and relevant findings.
And it's really important to note that AI is not meant to replace scientists. It's really a tool that can just kind of augment our abilities and allow us to ask more complex scientific questions.
Absolutely. And they highlight in this paper large language models, or LLMs, as a prime example of how AI is already transforming scientific research. I mean, LLMs are a type of AI that really excel at understanding and generating human language.
Yeah, and just imagine feeding an LLM, millions of scientific papers and asking it to summarize the current state of knowledge on a certain topic, or even like identify connections between seemingly disparate studies. I mean, this could really accelerate the pace of research.
It could. It would allow scientists to just, grasp the current landscape of knowledge and build on each other's work.
Right.
Much more efficiently.
Right.
But it's not just about, analyzing existing data, right? AI can also help make this scientific knowledge more accessible to a wider audience.
Right. Think about the traditional way that scientific knowledge is disseminated. Dense, jargon-filled research papers, published in very specific journals. And this really makes scientific knowledge inaccessible to anyone outside of that specific field.
Yeah, very niche.
Very niche.
And so this paper envisions a future where AI can help create, these interactive scientific papers with multimedia annotations, real-time simulations, and simplified explanations that could make complex concepts easier to grasp. I think that's really important.
Absolutely. I mean, imagine a high school student exploring quantum mechanics through an interactive simulation powered by AI. Or even, a policymaker being able to quickly grasp, the key findings of a climate change report thanks to an AI-generated summary. I mean, this is really democratizing access to scientific knowledge.
Right. It would make it more engaging, more understandable for students, policymakers, the general public alike.
Absolutely.
This brings us to another interesting application of AI in science, which is the generation of synthetic data.
Yeah, and in many fields, getting real-world data can be expensive, it can be time-consuming, or even ethically challenging.
Right.
So think about medical research, for example. It's really hard to collect enough data on rare diseases, and there are very strict ethical guidelines for conducting experiments involving human subjects.
Absolutely, and that's where synthetic data comes in.
Right, exactly. AI can create these artificial data sets that mimic real-world data. This allows researchers to test hypotheses and to develop models without needing to collect tons and tons of real-world data.
Right, and I think about climate scientists trying to model the impacts of climate change. They can use AI to generate data sets that simulate different climate scenarios, so they could test the effectiveness of mitigation strategies, for example, without having to wait, decades for real-world data to become available.
Absolutely. Or in drug discovery, researchers could use AI to, generate data on the interactions between molecules, which should help them identify potential drug candidates more quickly.
Yeah.
and more efficiently.
Absolutely. This paper also discusses how AI is transforming experimentation itself. Traditionally, experiments have been designed and conducted manually, often through like a trial and error process.
Right.
But AI is changing that. AI algorithms can actually now analyze existing data to identify the most promising experimental setups. This can help scientists focus their efforts on the most viable hypotheses.
It's like having an AI assistant that can look at all of your past experiments and be like, hey, based on what we've seen, this is the path to success for your next experiment.
Exactly. AI can also be used to automate experiments. This allows researchers to conduct thousands of experiments, simultaneously, collecting data, testing hypotheses at a scale that would be impossible for humans to achieve.
Absolutely. I mean, we're even seeing fully automated labs popping up, where robotic arms guided by algorithms are conducting experiments, they're analyzing data, they're even adjusting the experimental parameters based on the results they're seeing.
In real time.
In real time, exactly. And this is what the paper calls AI-guided iterative feedback loop.
I love that.
And it's being used in things like material science and drug discovery.
Yeah, and the paper also explores AI's potential to simulate entire experimental environments. And this is really valuable in fields like physics and astronomy, where testing theories can require complex and costly equipment, or even be impossible due to the limitations of current technology.
Right. Imagine simulating the collision of particles in a particle accelerator. I mean, that requires massive amounts of computing power.
It does.
And AI can help speed up these simulations. So it makes it possible to test theories that would have been computationally infeasible before.
Exactly. Or in astronomy. You can use AI to simulate, the formation of galaxies or the evolution of stars. And this allows us to explore these cosmic phenomena that are, billions of years in the making.
Right. And all of these examples really paint this picture of AI not as a replacement,
Right.
but as an ally.
As an ally. Yeah, I like that.
That can augment our abilities and help us tackle some of these just really complex and challenging questions facing humanity.
Yeah, it's like this team of, super-powered research assistants that can just process information, conduct experiments, and generate insights at a scale and speed we could only dream of.
Exactly. But to really realize that potential of AI in scientific discovery, we need to make sure that it's integrated into the scientific process in a thoughtful and responsible way.
Right. And that's where, this DeepMind paper proposes this framework for AI-driven discovery. They outline these key considerations and best practices for effectively leveraging AI in research. And the framework really emphasizes this importance of, strategic problem selection, data quality, model selection, and rigorous evaluation.
Yeah, let's start unpacking the concept of strategic problem selection. So AI is not this magic bullet that can solve any problem.
Right.
So it's really important to choose problems where AI can make a difference, focusing on what the paper calls root node problems.
Root node problems.
Yeah, so a root node problem is a fundamental issue where the solution can unlock progress across many disciplines.
So give me an example of that.
So think about protein structure prediction. Solving that problem has implications for drug discovery, disease understanding, and even material science.
Like the foundation.
It is the foundation, exactly. And so by focusing on these core challenges, we can maximize the impact of AI and accelerate scientific progress in multiple areas. But even with the right problem, AI success depends on the quality of the data.
Yeah, you can have the most sophisticated algorithm in the world.
Yeah.
But if it's trained on, biased or incomplete or inaccurate data, the results are going to be meaningless, or even worse, misleading.
Exactly.
And so the paper really stresses the importance of ensuring that the data is high quality, diverse, and representative of the phenomena being studied.
I mean, think about an algorithm that is used to predict patient outcomes
Okay.
based on medical records. If that data primarily includes, patients from one certain demographic, then it might not perform well for patients from other demographics.
Right.
And that could lead to really bad biases in healthcare.
Right. Absolutely. So it's not enough to just have a lot of data. The data needs to be carefully, curated,
Right.
validated to ensure accuracy and representativeness
Especially in fields like healthcare where AI is being used to make decisions.
that directly impact people's lives.
Yeah.
Okay, so once we have a well-defined problem and high-quality data, the next step is choosing the right AI model. And this is where things can get, a little technical, I think, because there's a wide array of algorithms available, and each has its strengths and weaknesses.
Right. And some algorithms are better suited for certain types of data. or certain tasks. And the choice of model can really impact the accuracy, the interpretability,
Yeah.
and ultimately the usefulness of the results.
Right, and the paper emphasizes the importance of considering, model interpretability, especially in scientific applications, where understanding the reasoning behind AI's prediction is really crucial.
Because, a black box AI model that just spits out a prediction with no explanation of how it got there may not be useful for science. Scientists need to understand the model to be able to trust it and to integrate those results into their understanding of the world.
Exactly, and this leads us to the final and maybe the most important element of this AI-driven discovery framework, which is evaluation and validation.
Exactly. Because it's not enough for a model to just produce results. Those results need to be evaluated, validated, to ensure that they are scientifically meaningful, reliable, and reproducible.
So you need to compare those results with real-world data, conduct sensitivity analyses to see how the model performs under different conditions.
Right, and really critically examine the assumptions and the limitations of that model.
Absolutely. And the paper also highlights the importance of peer review for AI-driven research. So just like traditional research, AI findings should be subject to scrutiny by experts in the field
Exactly.
to ensure rigor and validity. And this peer review process helps catch errors, biases, oversights, and make sure that the results are trustworthy and contribute to scientific progress.
It does. So to really kind of recap here, realizing that full potential of AI requires a holistic approach, one that carefully considers the problem, the quality of the data, the model selection, and the rigor of the evaluation.
Absolutely. It's not just about building smarter algorithms. It's about integrating those algorithms into the process in a way that upholds, the core values of science. Rigor, transparency, and a commitment to the pursuit of knowledge.
Exactly. Welcome back to our deep dive on AI for science. In this part, we're shifting our focus from those foundational principles to how AI is being applied across various scientific disciplines.
Yeah, so we've laid the groundwork, talking about how AI can handle those massive data sets, generate hypotheses, and even run experiments, right?
Right, so now let's actually see it in action. Starting with an area where AI has made remarkable progress, and that's biology, specifically protein structure prediction.
Yeah, this is a fundamental problem in biology, and it has implications for understanding diseases, developing drugs, and even designing new materials.
Absolutely, and traditionally, figuring out the 3D structure of a protein was really, really challenging, often taking years of lab work.
Yeah, and it was very expensive.
Very expensive, yeah.
But Google DeepMind's AlphaFold has really changed the game here.
It really has. AlphaFold uses these deep learning algorithms to predict a protein's 3D structure based solely on its amino acid sequence.
So it's like having a blueprint for life's building blocks without needing that tedious construction process.
Exactly. And knowing a protein's structure is crucial for understanding its function, how it interacts with other molecules, and how it might be targeted by drugs.
Right, so AlphaFold has become such a valuable tool across numerous fields, accelerating research from drug discovery to understanding diseases.
Absolutely. And speaking of drug discovery, that's traditionally been really slow, really expensive, and risky.
Yeah, like finding a needle in a haystack.
Exactly. You're searching for a molecule that interacts with a specific protein in just the right way to treat a disease.
Right.
And AI is starting to revolutionize that whole process.
Awesome.
Well, AI algorithms can analyze these huge databases of molecules and identify potential drug candidates that have specific properties, like the ability to bind to a target protein.
So instead of blindly testing thousands of molecules, AI can narrow down the search to the most promising candidates.
Exactly. AI can also predict a drug candidate's toxicity and efficacy, further streamlining the development process.
So it's like having an AI-powered chemist suggesting which compounds to focus on, and that could save years of research and potentially bring life-saving treatments to patients much faster.
It really could. And, moving on to another field being transformed by AI material science.
Yeah, material science, it's all about designing and developing new materials with specific properties, strength, flexibility, conductivity, all of that.
You name it.
Yeah.
And AI is changing how we approach materials design, moving from a trial and error approach to something much more targeted and efficient.
I remember we talked about inverse design. Can you remind me how that works?
Yeah, so instead of starting with a material and seeing what properties it has, we start with the desired properties and use AI to figure out what material would have those properties.
So I could say, I need a material that's as strong as steel, but as light as a feather, and AI could help me design it.
That's the idea. We feed the AI those desired properties, and it searches through a vast space of possible materials, predicting which ones are most likely to fit the bill.
So it's like having an AI-powered materials scientist able to design materials atom by atom.
Exactly. And this approach can lead to materials with unprecedented properties, materials we might never have discovered using traditional methods.
So what are some examples of these AI-designed materials?
Well, we're seeing the development of these lightweight, high-strength materials for aerospace and automotive applications, and that's helping to reduce fuel consumption and emissions.
So imagine cars and planes built with materials that are incredibly strong, yet amazingly light.
Exactly. We're also seeing the development of new materials for energy storage, like batteries and fuel cells, designed to store more energy, charge faster, and last longer.
These advancements could revolutionize everything from electric vehicles to portable electronics.
They really could. And now, let's shift gears to a field where AI's impact is becoming increasingly crucial: climate science.
Yeah, climate change is arguably the biggest challenge facing humanity, and AI is playing a key role in helping us understand and address this complex issue.
Absolutely. We've touched on how AI can generate synthetic data for climate models, but it's also being used to analyze vast amounts of climate data, from satellite imagery to weather station readings.
It's like putting together a giant puzzle, right?
Uh-huh.
AI can help us find those missing pieces and see the bigger picture of how the Earth's climate system is changing.
Exactly. AI algorithms can identify trends and patterns that would be difficult or impossible for humans to spot, leading to a much deeper understanding of climate dynamics.
And that understanding is crucial for developing effective strategies to mitigate climate change and adapt to its effects.
Absolutely. AI is also being used to optimize renewable energy systems like solar and wind power, making those technologies more efficient and reliable.
So AI can help us transition to a more sustainable future by making renewable energy sources more predictable and easier to integrate into the power grid.
Exactly. AI algorithms can predict the output of solar and wind farms based on weather patterns, allowing grid operators to better manage the supply of renewable energy.
It's like having an AI weather forecaster for renewable energy, helping us harness the power of nature more effectively.
Exactly. As you can see, AI is already making a significant impact across a wide range of scientific disciplines.
It's not just hype. It's driving real progress in fields that are crucial to our understanding of the world and our ability to address some of the biggest challenges we face.
It really is, and this is just the beginning. As AI technology continues to evolve, we can expect even more groundbreaking applications in the years to come.
But as we marvel at the transformative potential of AI, it's crucial to consider the ethical and societal implications, right?
Absolutely. In part 3, we'll delve into those considerations, exploring the potential risks and challenges of AI for science and how we can navigate this new frontier responsibly.
Welcome back to our final segment on AI for science. We've explored this incredible potential of AI to just transform scientific discovery across all these different disciplines, from biology to material science to climate change.
Right. And along with these advancements, it's crucial that we take some time to really address the ethical and societal implications that come along with this revolution, the scientific revolution.
It's like we're navigating this uncharted territory.
Yeah.
It's a landscape filled with so much promise, but also a lot of potential pitfalls.
Exactly. And I think one of the most pressing concerns is this whole idea of algorithmic bias.
Yeah, we touched on that a little bit before, but it's definitely worth delving a little deeper.
Yeah, AI algorithms, they learn from the data that they're trained on, right? And if that data reflects existing biases in society, then those biases can get embedded in the algorithms themselves.
So, for example, a facial recognition algorithm that's trained mostly on images of light-skinned people might not perform as well when it's trying to identify people with darker skin tones.
Exactly. And that could lead to all sorts of unfair or discriminatory outcomes, especially in areas like law enforcement or even hiring.
Right, or even in healthcare. Like, what if an AI model is trained on data that primarily includes patients from a certain demographic? It might not be as accurate for patients from other demographics.
Absolutely. And that could result in things like misdiagnoses, inappropriate treatments, and it could even worsen existing health disparities.
Right, it's a big deal. And so I guess the challenge then is to make sure that the data used to train these AI models is diverse and representative of the populations they'll actually be applied to.
Yeah, and that's not a simple task by any means, but it's super important for minimizing bias and just ensuring fairness in all these different AI applications.
Absolutely. So beyond just data bias, there's also the potential for AI to be used in ways that violate privacy or maybe even undermine human autonomy.
Right. I mean, imagine a system, an AI system, that can predict your likelihood of developing a certain disease. And let's say it's based solely on your genetic data.
Okay. Yeah.
So on one hand, that could be really valuable for preventative health care, right? But it also raises these concerns about genetic discrimination.
Like, what happens if that information falls into the wrong hands? Could it be used to, deny someone a job or insurance coverage?
Exactly. It's a very valid concern. And we need to start establishing some really clear ethical guidelines and regulations around this. We need to make sure AI is used responsibly and doesn't infringe on those individual rights.
Absolutely. And another potential societal impact to consider is, job displacement.
Right, because as AI gets more and more sophisticated, it can start to automate tasks that humans used to do.
Yeah, and that could lead to job losses in fields like, data analysis, running experiments, maybe even scientific writing.
Right, it's not necessarily a doomsday scenario, but it does mean that we need to be proactive and think about retraining and education.
So we need to equip the workforce with new skills, the skills they'll need to thrive in a world where AI is playing a much bigger role. And I think that means focusing on areas where human creativity and critical thinking are still essential.
Exactly. It's not about replacing scientists, it's about giving them better tools, augmenting their abilities so they can focus on those higher level tasks.
Absolutely. And I think it's crucial to remember that at the end of the day, AI is a tool.
It is.
And like any tool, it can be used for good or bad. It's really up to us, the humans who are designing and developing and deploying these technologies to shape the ethical implications.
It really is. We need to foster a culture of responsible AI development where ethical considerations are just baked into the entire process.
So it sounds like this involves collaboration between scientists, AI researchers, ethicists, policymakers, and the public too.
Absolutely. We need to have these open conversations about the potential risks and benefits, and we need to establish some guidelines for responsible use and just make sure that the development of this technology aligns with our values.
Right. And the DeepMind paper emphasizes this importance of transparency and explainability in building trust in these systems.
Right. If we don't understand how an AI system arrived at its conclusion, how can we trust those results? How can we integrate them into our scientific understanding?
Yeah, it's like having this magical black box that just spits out answers.
Yeah.
We might be impressed, but we wouldn't really understand the science behind it.
Exactly. So we need to develop models that are not only accurate, but also transparent and interpretable.
Meaning we need to be able to trace the AI's reasoning, understand those factors influencing its decisions, and identify any potential biases.
Exactly. And only then can we fully integrate AI into the whole scientific process, making sure that it complements human intelligence and makes it even better instead of just replacing it altogether.
Well, I think this has been a really fascinating deep dive. We've explored the transformative potential of AI for science, along with, all these critical ethical and societal considerations that come with it.
It really has been.
AI is clearly a very powerful tool that can accelerate discovery, help us understand the world better, and tackle some of the biggest challenges that we face. But it's our responsibility to make sure its development and deployment are guided by ethical principles, and that AI ultimately serves the best interest of humanity. So as we move forward, let's approach this new frontier with both a sense of wonder and responsibility, embracing those possibilities while still being mindful of the potential risks. And that concludes our deep dive into AI for science. We encourage you to continue exploring this fascinating intersection of technology and discovery, engage in those thoughtful discussions, and help shape the future of AI in a way that benefits all of humankind.
Thanks for listening to Mythos AI. Stay tuned for more concise insights. And remember to hit the like button and subscribe for future episodes.